Welcome everyone to Microsoft Build session. My name is Carlos Garcia and I'm the product manager for DeepStream. Today I have David, Edwin from Fractal Analytics, and Joe from Microsoft. We're going to cover Azure-enabled Vision AI solutions with NVIDIA for Enterprise and Jetson. If I have to describe the three most important challenges for real-time streaming applications, I will go with scalability, multi-sensor, and driving automation systems. Scalability, this is because we have billions of transactions across millions of locations. For multi-sensor, we have great solutions with DeepStream, where we have support for streaming cameras, USB cameras, MIPI cameras, LiDAR, and other sensors. However, there's a clear need for additional sensors for environmental systems. And driving automation, there's a clear need to integrate into applications in industrial use cases. We want to control PLCs and robotic systems in an efficient way that articulates all the information gathered by the AI systems. So let me expand a little bit on what I mean with the opportunities around industrial inspection. Up to date, the real-time situational awareness is what DeepStream enables to our developers. We can have queue management for different venues, tarmac automation at airports, and drive-through automation, improving quality of delivery. And of course, intelligent traffic systems in cities. However, there's a new opportunity around industrial inspection that requires deterministic systems and use of multi-sensor capabilities. This is unlocking a new opportunity for use cases around quality control, where there's a lot of important use cases around making sure lines do not go down, sorting and binning products in an automated way, and predictive maintenance. To support these use cases, we recently introduced a GXF runtime accelerator that, in conjunction, works with GStreamer, that is the foundation of DeepStream. So in this case, now you can have applications that run in GStreamer at full speed with cameras and millions of cameras in place and running accelerated extensions for real-time use cases. Everything runs from edge, workstations, and cloud, and benefits from all the solutions we have developed in DeepStream for zero memory copy between extensions and plugins, and developing applications in Graph Composer, C++, or Python. To give you an example of what I mean with this, envision this canonical representation of an industrial use case. We can have a production line with a worker operating and collaborating with a robot, where all that information is captured by LiDARs and cameras and streaming to the DeepStream plugins shown in green. But now you want to use that information with GXF to control a PLC and maybe the robotic arm. GXF allows you to do that functionality as it has scheduling capabilities that can be triggered by different scenarios. And finally, one important advancement in NVIDIA is the introduction of NVIDIA AI Enterprise. This allows us to bring AI enterprise-grade support for your deployments. So there is capabilities for pre-training your model, synthetic data generation, and optimizing your models with TAO. All the applications can be deployed with Triton Inference, DeepStream, or Riva. So now I'll pass it to David so he can talk about the DeepStream Accelerator.
Hi, everyone. I'm David Brown. I work closely with Edwin at Fractal. We're a consulting firm, and we helped build the Azure DeepStream Accelerator. This is a package of code available on GitHub that enables a custom model parsing path, as well as 30 pre-built NVIDIA models to run on Azure with a click to deploy button. This extends the Azure control plane into the edge, enabling customers and partners to easily and simply deploy what Carlos has talked about onto Azure hardware. Our custom paths also support edge hardware, meaning we can take Jetson devices as well as Azure Stack Edge devices and enable support of those devices through this architecture. This allows us to take advantage of all of the software that Carlos had mentioned, particularly NVIDIA's TAO Toolkit, as well as all of the frameworks around DeepStream, including GStreamer, in order to scale cloud analytics to the edge and enable seamless interoperability. What this enables is a host of use cases. These use cases scale widely across industries, particularly industrial manufacturing and quality control use cases are exciting for us because of the recent releases that Carlos had mentioned earlier around industrial inspection automation. Higher fidelity cameras are supported with the latest version of Jetson and DeepStream than ever before, meaning we can do higher fidelity industrial automation leveraging Vision AI than has ever been done in the past. This, in turn, lights up a whole range of possibilities, including NVIDIA's Omniverse suite, as we create integrated digital twins that are operating off of manufacturing processes in order to perform yield optimization tasks, taking waste and turning it into good product. This, combined with the physics simulation capabilities of Omniverse, lights up a whole new suite of AI, specifically deep reinforcement learning, as it allows for us to take defect detection to the next level. In the example packaged within the DeepStream Accelerator, we are doing defect detection on boxes. This is a simple showcase of what can be done from an implementation perspective using this accelerator. In fact, Joe and team have also created several models, including people identification, queue management, hazard zone detection, and PPE, personal protective equipment detection, that are packaged up and available through Azure's Cognitive Services that work with the Azure DeepStream Accelerator. Our team is working with Joe's to offer white glove services for any customer that requires assistance for onboarding. Similarly, Fractal has an in-marketplace offer designed to offer support for this whole life cycle, including provisioning and management of hardware through our Azure Marketplace listing. With that, I will turn things over to Edwin Webster, who will walk you through the code base of the Azure DeepStream Accelerator. Edwin?
Starting with the public GitHub release of the Azure DeepStream Accelerator, just want to take some time to focus on the overall conceptual kind of architecture that we have here. So at the heart of the DeepStream Accelerator is the AI pipeline container, and this allows for connecting to a variety of different video sources and processing those using your DeepStream pipelines. This could be bring your own model. This could be something that you would train using the other NVIDIA tools, such as the TAO Toolkit, and so on and so forth within integrations with Azure Machine Learning, for example. And then that's further extended through a suite of additional modules for applying your own custom business logic for making sure that the events that we're trying to detect, that we're taking the appropriate action based off of that. And we can then communicate the various insights that are generated from the edge to the cloud. And so with this, we provided a sample application through the GitHub example here, and this has a number of different assets that are included here. Once again, you'll see some of the graphics that we just saw, but it also contains an end-to-end workflow hosted through this Jupyter notebook for taking the data from a pre-labeled data set, training a custom model using the TAO Toolkit, exporting that in a format that is natively supported for inclusion with this DeepStream Accelerator. So what I've done is I've gone ahead and already run through this notebook in advance and deployed that. So what you'll see here is that we have, I've deployed this to an NVIDIA AGX or in DevKit. So if we take one step back here, we have, you can see we have the modules, they're all running here. And this is all controlled through one module called the controller module. So if I click on the controller module, I can look at the module, I can control its activity in the DeepStream Accelerator itself by modifying the twin properties that are present on that twin module, and it will orchestrate all of the changes accordingly. In this case, I've packaged the model from running the notebook and uploaded that to a blob storage. So here I need to specify where my blob storage is located, the zip file that has the assets with my model and any configurations that are required. And then this is the path within my zip file to my primary inferencing engine configuration, as well as any secondary or trackers that we would like to apply as well. And from there, we apply the module twin, and the model will then be downloaded, and it will be, the pipelines will be spun up. I will also point that within this configuration is where we can define things like regions of interest, as well as the links to the individual video streams and the sources that would be present there. So just to take a look at what one of these looks like, I can pull up the Azure IoT Explorer and start listening to the telemetry events. And what we'll see is that we start to get the telemetry, and in some frames we'll have detections for events, and others there may not be. But here you'll see that we have this concept of paths and of defect on these inferencing events. And what this is doing is it's detecting those, and then we can then apply that business logic that was mentioned earlier. And then that gets sent and routed to the cloud for further analysis. So what that looks like is, at the end of the day, is that gets uploaded. So both the video for the event of interest and the JSON representation of the inferencing events. We can go ahead and take a look at one of those. And it's all of the detections that occurred within a period of time is a JSON representation with the standardized inferencing schema. And then we bring finally the capability of visualizing that and integrating that through a widget. And what the widget looks like is it's with some very minor configuration to connect to the blob storage, as well as the edge deployment itself. What we're able to do is we're able to define those regions of interest with a real viewport from your camera, as well as play back inferences from specific periods of time. So if we wanted to select today, and then we can make sure that we have the day selected, we should get the list of inferences or events that were detected throughout the day. So here, this is just a few minutes ago. What we can do is we can play back these inferencing events, detecting the defect boxes versus the boxes that are passing the analysis here. And you can then take this and integrate this with other systems that you might have. You might have custom business logic for auditing purposes or downstream inspections or validation, as well as future model training and improvements there. So that's just a glimpse into the end-to-end capabilities of this Azure DeepStream Accelerator. We just scratched the surface on the overall capabilities. But this should give a great overview of what's possible with this accelerator that's available on GitHub. And with that, I will hand it over to Joe for an overview on the latest with the Microsoft Cognitive Services.
Awesome. Thanks, Edwin. It's exciting to see how the Azure DeepStream Accelerator can enable these new scenarios and how it turns on capabilities from Azure Cognitive Services for Vision inside the DeepStream environment. So I'm going to walk through some quick additional details on how the Azure Cognitive Services Vision capabilities work and how they might light up in these scenarios. So Azure Cognitive Services for Vision is part of this broader Azure AI platform that includes scenario-based services like Form Recognizer and Video Analyzer, as well as cognitive services that enable you with pre-trained models and the ability to customize for your scenario. Vision, it includes a set of capabilities around OCR to understand text, face, recognition and detection, image analysis to understand content, and then spatial analysis to understand video. All these are built on top of a core set of investments around foundation models like Project Florence. Foundation models have been pre-trained on vast amounts of data to enable basic understanding of the world around us. They come in lots of different flavors, including Florence for vision, which can identify almost any object. Z-code covers language and translation as it's trained on hundreds of different languages. And GPT, which can understand and generate language and code seemingly like magic. In vision, we've revamped the Azure Computer Vision service, accelerating it with a set of Florence capabilities like captioning here that is able to identify the animal, the vehicle, and the people in the scene, and enables scenarios like workflows and notifications and search to be built on top of the data that it generates. When we think about integrating this with DeepStream, we look to hybrid configurations where we leverage the edge for everything it can do, getting the maximum value out of the edge, and then utilizing these foundation models in the cloud to add additional insight and actionable intelligence. Just one example here shows that when we upload video to the cloud, we can enable a user to summarize the video, getting a text representation of the video, highlighting key activities that occurred, like people climbing a ladder, moving boxes around in this warehouse. And then we can find specific frames based on natural language in that video. So this is just one example of how these foundation models can enable enhanced capabilities using video captured from DeepStream devices. You can try this out yourself at aka.ms/Vision Studio. Additionally, we'll have a build session that goes deeper on this called Build Apps with State-of-the-Art Computer Vision. And then there's additional resources covering the previous topics that we covered around the Azure DeepStream Accelerator. Here you can find the links, and the NVIDIA DeepStream SDK and Jetson Orin device. And with that, I'll transfer back to Carlos, and he can close us out.
Thank you, Joe. So before we finalize, I want to be sure that you guys can check the NVIDIA virtual booth at the show, where we have additional demos and information regarding this session. There is information on how to become a developer at NVIDIA and join the developer program, and additional NVIDIA sessions during the show. Thank you for your attendance, and happy deep streaming.
Thanks, everyone. Bye.
Bye now.